actually what I did during my time of this fellowship. So, and this is the University of Hanover, this is Braunschweig, and this is now the this is the building of the RISM at Shinshu University in Japan. So, but the motivation is actually that, you know, so today there is a bit, wait a minute. So yeah, today there is a lot need for chemical processes, especially for instance for do new environmental friendly technologies, etc. And 80% of these chemical processes in industry have a catalytic process. So being heterogeneous catalysis, the most wide technology applied in that case. So, and to catalysis happens, we need a catalyst, for instance, a nanoparticle, a metal nanoparticle, and then the molecules will go to these nanoparticles, and then the reaction will occur faster. So, but still, the understanding these catalysts is really difficult, especially because they are really complex. Like this is not nanoparticles being simply floating, but they are mostly attached at a metal support. Metal oxide support, for instance, and then there will be interactions with it. If one want to do calculations on it using density functional theory, which is based on chemical and quantum chemical calculations, one can do that, but it is really computational expensive, and this is not, and then one cannot calculate a big system. But now, this is about AI, now new emerging neural network potentials. This is the name of new computational models that can actually do similar things like the quantum chemical calculation. These are now emerging and they could be useful to calculate such kind of complex systems. And this is what we are doing we are not developing these potentials, but we are testing them and we are applying them to calculate complex catalysis at Shinshu University. So, and one example are, for instance, catalysis uses for nitrogen synthesis. As you can see, these catalyses are not so simple. This is a nanoparticle. The nanoparticle is attached into a support, and there are so-called strong metal support interactions where the material of the support is going up to the nanoparticle. And this makes actually that these catalysts have a really good catalytic activity. That means the reactions occur on these catalysts faster than in common catalysts. And this is, but the reason why it's happening is still unknown. So actually we uncovered why this reason is happening, but I would not like to go so far. I want to show something a bit special that we discovered, that we tried and worked on the way. So, and the difficult part to do those kind of material modelings is that these lanthanum and Syria cations are partially wrapping the nanoparticle, and this is really difficult to model. One cannot calculate it using quantum mechanical calculations. So, and the current computer technologies up to now. So, but using this neural network potential, we could, for instance, create such kind of models. As you see, these are real computational models of the nanoparticles. As you can see, this is the visualization, this is experimental observation, and these are the models that we create. And if we put some kind of, if we reduce the support, that means if we take the oxygen out of it, then and we calculate it, then we observe that some of the atoms were also going on the nanoparticle. So, and these kind of simulations took a lot of thousands of iterations. This is not possible using DFT, but using this neural network potential, we could achieve that, and then we could also, for instance, understand the charge distribution on the catalyst, which is also really important to understand how the reactions are occurring on it. So, but then we also, this is not enough, because if we are talking about catalysis, we need some molecules that will react on the catalyst. So indeed, in that case, we account also on the reactants. Indeed, in that case was nitrogen. And we create various configuration of these reactants on the nanoparticle, as you can see on different sites. And then we could calculate at each site the absorption properties. In this case, we could calculate, for instance, how the molecules are vibrating to each other, which means if a molecule is vibrating so really fast, then it is difficult to break. But if a molecule is vibrating really more slowly, then it is easier to break. So, and in that case, we could also not only calculate the nanoparticles and the complex system, but we also could calculate a spatial map of and know the distribution of the properties depending of the molecule absorption site. Good. And then we could color, of course, that means we could color each property these points on the nanoparticle depending on the proper absorption property of the molecule. So, but the most interesting part here is not that we could model it. Of course, that is nice. But the most difficult part between computations and experiments is that it is difficult to make a bridge. So one can calculate something, and then one can see trends compared to experimental data, but it is difficult to have really a good bridge between them. So we did a lot of calculation, and then we calculate, for instance, the vibrational frequency, which is the IR spectra of the absorption molecules on it. So this is just a lot of material science, but if we calculate it in average, we could get, this is our simulated results, and these are the experimental data for different temperatures, and as you can see, they are really corresponding to each other, and this is really difficult to get. Eugen knows about this, that it is actually really difficult to compute such kind of similar progression of the curves. So, and we did by having a big space of different configurations, and this is now, since we could show here that what we need to reproduce experimental data is actually to find good models and have a good computational, for instance, good computational models that are able to be as accurate as quantum chemical calculations. In this case, neural network potentials are making a breakthrough in material science, and if we apply such kind of complex models, we can get really good agreement with experimental data. And this is what we are actually doing in Hsinchu University. Nevertheless, so the take-home message is that experimental data is reproducible if the complexity of real system is sufficiently reflected in the computational methods. But of course, one needs, of course, a neural network potential that can handle these complex systems, otherwise it's not possible. But in our case, while the system complexity is not a problem, a drawback is the need of useful clues about the real atomistic picture, like we get in this publication to create our models. So, and as it became lately possible from experiments with atomic resolution, any kind of collaboration in this direction is highly welcome. And I hope this gives you a small overview about the kind of material science computational work that we are doing at Hsinchu University. And thank you very much for your attention. So again, this work was done by a fellowship from the Alexander von Humboldt Stiftung. Thank you very much. And the GSPS, Japan Society for Promotion of Science. Thank you very much.
Thank you, Gerardo. So any questions? Please raise your hand and we can proceed to the questions if you have any for Gerardo. Otherwise, I would ask the next speaker, Hang Yu, to be ready. So we'll wait for one more minute if somebody has any questions. So just out of curiosity, Gerardo,
Yeah,
so this was a joint collaborative effort from your university in Japan and a base institute in Germany?
and actually, this was all done in Japan, but the Alexander von Humboldt Stiftung from Germany was also being behind this. The foundations are collaborating, but not the institutes. That is actually the host in Japan was the only one behind my supervision. Yeah.
Okay, great. So a great example of international collaboration.
Mm,
Yeah.
thank
Thank
you.
you. So I think we'll have time for some questions if the audience have at the end of all the talks. So
But
thank you again.
okay, but I can just say something really fast.
Yeah,
So
please.
if especially people coming from China or India or Asia or Japan, if you are interested to have stay such like me that I could go to Japan from Germany, there is also the other way around. If you apply for an Alexander von Humboldt fellowship, you can go from other countries to Germany to do research. So please visit the site and maybe you can find some kind of possibilities to do that. That's it. Thank you.
Yeah, absolutely. So yeah, anybody in the audience, if you're interested in exploring these opportunities, please go ahead. And thank you, Gerardo.
Thank you.
So next up, I would like to invite Hang Yu. Can you please share your screen and try to see if your presentation comes up? Thank you.
Sure. Thank you. Hey, sorry. Yeah, my program just crashed. Yeah, I'll share my screen right now.
Okay, no issues.
Yeah, can you see the screen?
Not yet.
Oh,
Yeah, now it's coming. Yeah. Yeah, we can see your screen.
oh,
Please.
great. Thank
Okay,
you.
thank you. Thank you. The
Yeah.
floor is yours. Thank you.
Yeah, thank you. So my name is Han. I'm from University of Illinois. So I've been working through the industry for a couple of years in e-commerce and investment side. So yeah, there's been a couple of work I've been working on. So today I would like to present the on the AI governance, mainly like a mini review for the work we've been doing. So this talk will be mainly on the industry side. So yeah, maybe quite different from what was presented just now. So please bear with me. So the talk I'm going to discuss is on AI governance in industry. So what are the frameworks, challenges, and how do we proceed forward? So as AI intelligence continues to integrate into our life and society, so the need is becoming more and more critical. So today we'll explore the path forward on the AI deployment. So yeah, maybe let's start with an overview. So AI is rapidly transforming our industries worldwide, offering significant benefits, but also introducing challenges worldwide. So for what AI governance is about ensuring that AI technology are used ethically, transparently, and responsibly. So, so in this, I will discuss what this involves, the challenges organizations face, and strategies we can use to accommodate this change in the dynamic landscape. So what is AI governance? AI governance is about ensuring the ethical transparency of AI technology. So it aligns with ethical principles and regulatory requirements, as well as societal expectations. Some of the key components include transparency, which is ensure decisions made by AI systems are understandable, and accountability, which is identify who is responsible for the outcome. Bias mitigation, reducing unfair bias in the AI systems, as well as AI privacy, protecting our data for misuse, and as well as risk management, which is addressing the potential risk before they occur. So yeah, there are in addition to these ethical principles, there are a couple of industrial standards that's already being outlined. So in Europe, we have this general data protection regulation, which sets strict rule for data privacy, while in EU AI Act, it aims to classify AI systems by risk levels. In the United States, we proposed frameworks focus on AI transparency and accountability. And in Asia, in countries like Singapore, we have a leading with balanced and innovative friendly regulations. However, there's still room to harmonize these efforts globally to prevent regulatory fragmentation. So, for example, in the ethical considerations, so ethics play a critical role in AI governance. Some are some pressing considerations, which is bias mitigation. So AI system must be designed to avoid discrimination against certain groups. And as well as transparency, it's essential to make AI decisions interpretable for users and stakeholders. And also very important, we need to have a privacy with AI relying on large data sets. Safeguarding this individual data is very critical. Organizations must use these ethical considerations in their AI lifecycle from the design to deployment. So with this, we have a couple of challenges in AI governance, which is first, regulation inconsistency. So different regions have various rules, and making the compliance very difficult for global companies. Global companies has to adopt each individual rules separately for each regions. And second, for stakeholder alignment, balancing the interest of policymakers, business, and the public is not easy. Often they have different requirements, and we have to mitigate the requirement to comply with the regulations. Third, there's also operational ethics. So translating these principles into actionable policy can be complex. So for example, we need to regulate the employee actions when we are respecting data privacy. So all these come together. There's a constant tension between the engaging innovation and the managing risks. So for example, I can give a couple of industrial cases. So maybe let's first look at the healthcare AI. So in healthcare AI, we help to ensure patient safety by identifying bias in diagnostic tools. So one example we have is that, so I've been working with a healthcare system before, and we also have worked with IBM Watson. IBM Watson was developed to assist doctors by analyzing patient data and recommending treatment options. However, it's faced a couple of criticism and bias. for training data and inaccuracy recommendations. So what is the mitigation is that we incorporate more diverse data sets and engage medical professionals in the iterative feedback loops. So this helps to implement clear explainability protocols to ensure doctors understand how the recommendations are made and what other data is based on. So with this improved accuracy and trust in the system, the AI supports doctors so without compromising patient safety. So another example is in autonomous vehicle. So the challenge is that, for example, we can use the example of Tesla. In Tesla's autopilot system is facing like a strict scrutiny over safety incidents. So there's a couple of questions raised by the government and public about the liability and the lack of transparency in AI decisioning. So what they have done is that they have improved the public documentation about the autopilot's ability and the limitations. So they also began integrating the driver monitoring system into the system to ensure the human oversight. So the outcome is good. We have improved user awareness and better regulatory compliance, as well as we balance innovation with safety and accountability. So the last example I can use is on the social media side, which is Facebook. So for Facebook, AI is used to detect harmful content, which is often on the offensive materials and speeches. However, it has to mitigate the balance between free speech and offensive materials, which is often raising criticism from the public and also generating potential bias against certain groups. So what Facebook has done is that it expands human oversight into the moderation process, and also have published transparency reports dealing with details on the AI system, how to classify and act on the content. There's increased public accountability and create a hybrid system. So in a way, it didn't, although it didn't resolve the problem completely, it aligned the content moderation practice with the public expectation and ethical considerations. So from this, we can derive a strategy for governing AI governance, which is to develop comprehensive policies and frameworks that address the transparency, accountability, as well as ethical risks. So once we have these policies, we will engage with stakeholders across sectors and collaborate with different, for example, governments, industries, as well as communities. So with their understanding, it is critical to enforce this policy. So with that, we also have to invest in the monitoring tools to continuously assess the performance of AI systems, as well as our current policies. And also, we want to foster an ethical culture. So we would like to train the employees and create awareness, so which is critical to the responsible AI usage. So for the path forward, so we can see that global collaboration on the regulatory will be essential for harmonizing regulations. Education and awareness campaigns can equip both business and as well as the public with a tool to address AI governance challenge. So by fostering innovations, we can align companies with societal values, ensuring the system are both effective and trustworthy. So in conclusion, AI governance is no longer optional. It's critical at this stage. So organizations must proactively address these challenges by adopting ethical frameworks, engaging stakeholders, and also leveraging technology responsibility. So with a collaborative effort, we can ensure AI not only drive the innovation, but also align with societal values and expectations. So yeah, thank you. That's all I want to talk about. Thanks.
Thank you, Hang. Very nice presentation. So anybody has questions, please raise your hand, or you can also type in the chat window. Okay, so just a quick query. So because governance and auditing pretty essential for enforcement, especially on big corporates, because they're the ones which are working exclusively on AI and so many different models and frameworks. So in your experience, like for example, some of the regions or countries may not have very stringent AI laws and regulations. So how do they like manage? Because especially for small countries, if they do not have an AI governance or auditing regulation yet, how do you think is the best strategy from a end user perspective?
Yeah, that's a good point. So, for some some regions has very strict laws. Right now, it's well better protected, but some regions are still falling behind, and that actually comes into the first the company's the responsibilities. We have to for each regions we not only have to adopt the local regulations, but also we have to enforce our company regulations, both for the end users as well as for the employees. So once we have this in a way that big corporations, this is better enforced and we will have better protections. So yeah, for the end users, maybe we can we don't have a yeah, we don't have actually a transparency oftentimes with what happens at the background. So oftentimes we have to trust the company, and sometimes the big corporations may be a better choice for us. And if we don't have a choice, maybe yeah, for the small corporations, we have to understand what is happening at the background, and maybe we have to check with them. And yeah, oftentimes it may take longer to understand what is happening. So yeah.
Okay, thank you. So I would like to, yeah, I think there is one question in the chat window. Mangao, he would like to ask two questions. First is, AI is a black box. What is your opinion?
Yeah, that's a good point. So from what I understand, oftentimes when we develop a tool, we understand what exactly is happening, like a machine or something. We will understand what exactly is happening and what is causing this. But for AI, it just becoming too large and too big. It has millions, I mean, thousands of parameters that we as a human can't understand it all with what is happening. But we are actually developing tools to understand it part by part. For example, we have a tool that's actually tune up and tune down certain parts of a neural network, and we will see how the AI is reactioning. Maybe the response will be happier, and sometimes more yeah, more angry. And so this would help us to better understand what is happening in the box, and as well as but since AI is happening growing faster and faster, and we have to have this, it's more important to have this regulation on this AI framework, so that yeah, so that we can regulate what is happening.
Okay. The second part of the question is, what problems does AI not have the ability to solve?
Actually, what I think is that AI currently is capable of doing a lot of tasks, but there are much more tasks it's not able to do right now. For example, it can understand what we are talking about, but it's in a way that is still mimicking what we are talking about rather than actually understand our emotions and as well as the content that we are relating to. So in a way, I think AI currently is more like a tool we can still leverage on rather than it's capable of doing everything that's we are doing right now. So yeah. So I think
absolutely.
Yeah.
Yeah, absolutely. So yeah, emotions, I think still a long way to go, but yeah, I think they've already started experimenting with some of a subset of human emotions if machines can, emulate and repeat. Okay.
I have a question.
Yeah, please, Ravi.
Okay.
Hi.
So thank you for your presentation.
Sure.
I wanted to know your point of view, given the situation that the AI is still in the development phase. There are, industrial adoption are happening, but it will take some time to fully adopt. What is your point of view, given a consideration that we have to choose one or prioritize one, ethical concern or the safety concern at this point of time, which should be the priority for the developers or uh, organizations which are building these models for the end users? What is your point of view?
Thank you, Ravi. So your question is about whether we should choose ethical or safety, is it?
Which should be the priority?
Yeah, I think ethical and safety are both very important. So it is something that we should adhere on. So, but this, I think, for both of these, we can adopt it together with the regulations. We can accomplish both the safety and the ethical part. And I think what is contradicting is that the innovation part. So, yeah. So, for example, so there was an experiment that there was a mice. If we cut off of its emotional part, so it's becoming more like what AI is doing right now. So which is accomplishing the task, but is not able to feel our emotions. But without this part, it actually doesn't understand a lot of task it's doing. So I think what AI is like the mouse without the emotional part. So as we are progressing, I think a lot of companies are actually now trying to understand how we can equip the AI with these emotions. So this is becoming kind of dangerous. I hope it doesn't actually trigger something dangerous right now. But yeah, so in my opinion, we should actually regulate how AI development should be going on. So this is for the ethical and both ethical and safety concerns of our development, but it may contradict with AI renovations. Yeah.
Thank you.
Thank you.
Yeah, thank you. And I think we can continue those questions after the talks are over. So thank you, Ravi. Thank you, Hank. And next up is Norbert Preining. I'd like to invite Norbert. Can you just please share your screen? And
yes, the screen should be shared now. Okay.
Yeah, great. Thank you.
Yeah, thanks everyone for joining. So I'm a bit in the line with the previous talk. I'm not presenting here from university research, but AI in business at Mercury. A bit of short introduction. By education, a mathematician, logician. I've worked more than 20 years in academics at various universities. Then worked for nearly 10 years as research and developer in various IT companies, and currently work for Archive, the preprint server where you all get your papers from at Cornell University, and still working also contracting for Mercury in the AI and BI teams, and have worked at, as I said, at various universities and companies recently. So what is Mercury? For those who don't know, it's the biggest client-to-client marketplace in Japan. We have about, I think it was in 23 million active user monthly. So that's big. We have about 3 billion listings, GMV about in the 1,000 billion, so 1 trillion yen sales. And yeah, so it's huge. And that means also we have a lot of data, and we just try to use this data in our AI setup. Just to be clear, this is not my work, also not only my work. We are talking here about several big teams working on this. I want to special mention 2 people. Alexander Zagniotov, he probably kicked off. He has already left and went back to the States to some companies, but he probably kicked off active AI usage at Mercury several years ago. And Paul Willott, he pushed long forward. He's still in Japan, working also in a different AI company, pushed forward, especially embeddings across the whole company. I think the 2 have done the most for the AI distribution within our company. So a quick overview what I'm talking about. It's just about where we use and how we use AI in a huge setup like Mercury. I will just pick a few things. The one is improving search, because search is one of the most important items in Mercury, then improving listing, and improving our AI infrastructure, and then a few mentioning of those. Okay, improving search in AI. So search at AI, it's the primary discovery mechanism, right? If you want to buy some item, then you search. So it's mostly mobile app. We have a web application. People search on the mobile for applications, for items they want to buy. So search drives our main market drive. It's extremely critical. So if we lose like 50 milliseconds, we lose like millions of yen, just to be clear. It is originally was powered by a classical NLP-driven Elasticsearch keyword search. And nowadays, after post-retrieval, we do AI ML re-ranking algorithm that is decoupled from the Elasticsearch. So how does it normally look? Well, a traditional original search architecture is while you have a client sends a request that goes all the way down to Elasticsearch that returns a few items that match. Elasticsearch is quite good in retrieving items, but I mean, everyone working on search knows that it is far from the best. And so that's not really the optimum. Typically blind spots, really problematic things are ambiguous keywords. So for example, here, One Piece. Some of you might know One Piece is a very famous manga in Japan, but it's also a word for a dress. Japanese call a dress for females also One Piece. So searching for One Piece is very ambiguous. Other things, personalization, semantics is also difficult. So what does re-ranking? Well, it just takes the listings order that come back from Elasticsearch and throw in a re-ranking function that runs over relevance. Of course, we have trained an AI model on relevance. Relevance is interaction with items. So there's a lot of work going on with the hope that relevant items, if they are higher in the search list, so higher on the top on the first page, then more people will buy, and this gives more money coming to the company, of course, also. So how does it look nowadays? It's just we have a client sends to the search, we do some further processing, then features, LTR. So it's getting quite complicated. You always have to consider that we are talking about tens of thousands of requests per second search. We have latency requirements of 100 milliseconds for the whole. So everything has to be very fast and efficient. That was the one. That is actually the one part where I have actively worked on the re-ranking model, like putting this into, so developing a re-ranking model and putting it in production. Another item is listing. So of course we need people who sell their stuff, and selling stuff can be hard and tedious. Like, right, you have to make photos, you have to write descriptions, you have to set the price, you have to search the category, you know, all these kind of things. So to make this easier, what we have done is like, so this is the detailed user experiments and mostly in Japanese, so please don't worry about it. But you see that the blue bars are those that are actually AI driven and nowadays LLM. So what you can nowadays do is you just make a photo and select the minimal data and the rest is automatically generated and you just check it then. So what is automatically generated is the description, the category, even a price suggestion by comparing it to other items in this in Mercury. So yeah, this is practically what I just said. Here's a short example. You just make a photo, just tell them, okay, give me a suggestion. The suggestion gives you the title, description, money, everything, and it's already listed. So this is a lot of AI going on here. We have LLM stuff going into the description creation, recommendation system, search, ranking, everything goes in here. Last but not least, we have huge improvements in the AI infrastructure. The big problem is that we had originally everyone, so it's a huge company and lots of teams, and everyone used their own embeddings and different types of embedding. So like the recommendation engine, the search, the listings, all of them used slightly different models. So what we then did is, well, could we take our one model, train it on our own data, and then use this embedding for all our services. So this is first reducing complexity because everyone can reuse this and faster, more efficient, and we have professionals working on this. So yeah, this is one of the things we have done in the last year that is going on, is like providing vector embeddings for the whole company. Yeah, we have fine-tuned cyclic models. We run all this in Vertex AI and in Vertex AI for our cloud services, and we have inferences via the model very fast. Just quick, because time is running out, quick mentions. We do a lot of other things with AI. One typical expansion is synonym expansion in search. So this is quite tricky because we want to search, well, Japanese people use several different alphabets like hiragana, katakana, kanji, and romaji. And so we have to expand to the search for different, like here an example for Louis Vuitton. We want to actually, what is inputted in Japanese to expand for searches. Other thing is image scores. It's obvious that in a client-to-client marketplace, good images makes the product sell better. So we are working on this, work in progress on image evaluation and scoring. This should help also the user to get better scoring, better images, make them more interesting. Okay, to conclude the stuff, so AI at Mercury, let's put it this way. So there are three values that are all in Mercury. We always, so these are guiding principles. One is be a pro. What does it mean? Like we have frontline AI development. So everything what we are developing here is often published in the biggest AI conferences. Our development teams go to those conferences to present the research results. It's difficult because we have these strict guidelines and deadlines. And if something bad, happens, right, then a lot of money is just blown out of the window very quickly. Then go bold. So because we have a very stable system, we can try out fancy stuff, fancy new stuff. It's no problem to try things out that are like upcoming and you don't know. Like, as I mentioned, for Paul started doing embeddings when embeddings were just really the new kid on the block. And so you have to have a vision for the product, but was one. And all for one is like everyone should help on improving AI infrastructure. So we are trying here also to be on the front line with the newest tools. As I said, everything I presented here has been presented at various international conferences around, and this will continue. Okay, finally, if you have any questions, feel free to contact me. I will forward you and put you in contact with the respective managers because we are talking about several different groups here. My LinkedIn address, my personal email, my company email. Okay, thanks for your attention.
Thanks, Albert. That was pretty quick and very crisp. So anybody has questions for Norbert? Okay, so from my side, I just have a quick question. So does your platform also allow voice search? Is it like integrated into your platform?
What kind of search?
Voice search? Voice? Voice. Like
Voice.
Yeah, voice. Yeah.
No, not this is because this
okay.
is, well, it is integrated in the sense you can use it by using the AI voice to text system of the mobile, since it's mostly mobile app with, let's say, 80% is iPhone in Japan.
I see.
This voice to text is normally integrated into the mobile application.
Ah, okay. Got it. So there is one question in the chat window from Mangao. So what are the unique features of Mercari compared to other competitors?
Very good question. Probably a lot. It was Mercari was the first. That is huge. It has an incredibly good distribution mechanism. I think I can't consider this because I lived in many countries. So you can actually send client to client items without you knowing to whom it's sent and without the receiver knowing who sent it. So this is all because we just print out barcodes, put it onto the delivery service. The delivery service does everything. That keeps a high level of privacy because payments are not direct, because payments also go via Mercari, via the company. So there is no like danger of leaking of private information, like, okay, you sent me something bad, I come after you, or something that happens in other marketplaces. That is, and it's very efficient. And then it's just a pure number of listings. We know from our KPIs that listings is one of the huge part, and that helps a lot. Another thing is that we have cross-border now. So we have America, Taiwan, and I think further countries are coming up. Where you have not only the local but also cross-border listings, which is something that well, a lot of Japanese manga or items are very sought after in other countries, and so that drives a lot of business also.
Okay, I hope that answers your question, Lang. So, thank you, Norbert. Thanks a lot for your participation and your talk. So next up. Next up, I'd like to invite Lin Jia. So can you please test your presentation? Can you?
Hi. Yes.
Try to share. Yeah. Okay. It's already tested. Okay. Please go ahead. Thanks.
Yeah, it's already tested. Yeah. Could you see my screen?
Yep. Yeah. Please go ahead.
Okay. So, hi everybody. My name is Lin Jia. I'm currently a researcher at Ecosys, Austria in Switzerland, and I'm very honored to be here to present my recent work. And the title of the work would be presenting redox potential by graph-based machine learning methods. In the recent years, as we know, machine learning has revolutionized the chemoinformatics. At least it's trying to do so. So by leveraging those machine learning algorithms, we can do a lot of works like predict properties, to reaction process design, to molecule generations, etc., etc. And today my talk will mainly focus on the molecule property predictions. So why do we use AI in this kind of a task? As we already talked by our first speakers, that in many real life contents, that in many computations we may need very high time complexity. So when we try to use these machine learning methods, we have two goals. First, of course, we want to lower the time complexity, and we want to have the comparable accuracy. And in addition, we would like to try to have some candidates for our real experiments so that we can lower the costs. So of course we can predict all kinds of properties, as we know, like molecular energies and properties of polymers. And here in this content, we will cover the redox potentials mainly. And the whole pipeline is like a general machine learning pipeline. There are like several key steps. First, we have the data collection steps where we collect all these molecules, polymers, with their redox potentials collected by our collaborators from a chemistry lab. And we have this with those we have the descriptor representations, which can be computed by some softwares very quickly, like Balloon and RDKit. And the goal here is to show that even with this some low-level accuracy descriptors, we can still have some very quite of good results for predictions. And in the meantime, we will have this redox potential baselines computed by DFT. Of course, we can still have different levels of DFTs. And then we train a model using these pairs of data sets. With these models, when we have a new compound, we can again compute all the compute these descriptor representations, and we give these representations to the machine learning models, and we will have the predictions as we want. And we already published this paper on journal. So what's our approach here? So mainly we would like to use the graph-based models to model our molecules. So why use graph-based models? First of all, the graph-based models are quite powerful now. For instance, it can model the connections as well as the entities as well. At the same time, so you can have different kinds of features on both the relations and also the entities. As you can see here, the graph-based machine learning method has already been used in many different types of fields. For instance, social networks, handwritings, etc. And for the molecules here, we could model the atoms as the nodes and the bound types as the edges of these graphs. But of course, you can also have different kinds of ways to present it, represent it, as we will cover it later. So we will quickly go through some graph-based representations, which will be used for the graph machine learning methods. First, the graph at distance, which is based on the measurement of the distortions between the two graphs to give a distance between the two graphs. And then this distance will be used for further machine learning methods. And we can also use the graph kernels, which maps the graphs into a kernel space and then have the inner embeddings in those space. And of course, now we have a very hit field of graph neural networks, which mostly use message passing ways to gather information from nodes and edges into graph level vectors in our case, and use these embeddings to do the predictions further. And to our applications here, we have gathered the data sets which is called redox oxidation database, which have 159 data with commonly compounds, which is representative in this field. And the goal here is to predict the redox and the oxidation potentials. And here's the distributions of the data. I will not go into too much details. And to do the machine learning, especially the graph-based machine learning on the molecules, one of the very important part is to design the descriptors. As we will show later, that we say that with different descriptors, we have a very different prediction accuracies. So here we tested several different descriptors. The first is a very common atom plus bond types. And the second, we expand our features on the atoms and also the bondings with the one hot features. As you can see, we have different kinds of features here, and also on the bondings. So in this way, we can enrich our descriptors to give more information to our models. And this, lastly, we have another descriptors on the bondings. Instead of this one hot features, we try to capture distances between the two atoms at the edge of these bondings, and we use these distances as a feature on the edges. And we have tried different kinds of graph learning based learning machines. As we mentioned before, we have got graph kernels, GNNs, and GEDs, etc. And we also compared with the vector-based models. So as we can see here in our results, we can see that for graph-based models, especially GNNs, we can have quite better results based on the traditional vector-based models. And as I mentioned before, if you can see each of the columns, you can also see quite a big difference between different using different descriptors. For instance, when we use a distance, which can have the best results on the redox potentials, and for the oxidation, we can also have quite good results with a one hot descriptor, which means that this is very important to design the descriptors at the same time to choose the models. And we can also say the correlations here, that using the best of our models, one of the GNN, MP, NN on the distances, we can have quite a good results here. And also, as we mentioned before, one of the very important part is that using these models, we can have a quite a lower time complexity. As you can see here, especially when we use the GNNs, we can have a very low reference runtime, which is very good for our results. So to summarize, we have tried to use different kind of graph-based machine learning models to predict the redox potentials on some featured compounds, and we also try to build different kinds of descriptors to further help to use this machine learning graph-based machine learning models. So in the future, of course, as we are collaborating with a lab, chemistry lab in Rouen, Normandy of France, and we will pursue further for our property prediction tasks. And currently, we are also trying to do some reaction process design tasks, and also in the future, maybe the molecule generation task, as also a very hot research area. Okay, that'll be all for my presentation today. Thank you very much. Any questions?
Thanks, Lin. Any questions from the audience? Yeah, Eugenio, please.
Hi. Well, thanks for the excellent presentation. My question is, the main goal of your research is just to go for what the people do in solar cells about bandgap engineering, just to have it more in the field of dye-sensitized solar cells or organic solar cells. Are you in that
currently we are more into the, the redox potential part, the molecule property potential part, prediction part, with with all the with all the models we design. Of course, for now, most of the models are like based on baselines, but we also have some kind of models which designed by ourselves. For instance, GEDs, we have some kind of a ways to optimize it as a fitted ones. And in the future, we would also explore different kind of models as we design it ourselves, and of course with other tasks.
Okay, so no, because I'm working in metal organic frameworks with modification with dyes, and I have very robust experimental information from EPR, and as the goal in the future is just to go maybe for something that can go in the photocatalyst, water splitting or solar cells. We need just to know the redox potential of the molecules that we attach to the metal organic frameworks. So I would like just to be in contact with you in the future in this case.
Sure, of course, no problem. As you can see, it's as you know, it's not very easy to gather a lot of molecule data. So for now, we are currently just focused on this as quite a small data set. But I think it would be very nice to have a different data or different applications from your side. It would be very interesting for us as well.
Perfect. Yes, I'm in collaboration with one group in Bavaria, so there they are all. Okay. So let's stay in touch in that case. Perfect.
Okay, no problem.
Yeah.
Okay.
Great talk.
Just one more question. So from Mingao, so at present your field is also using AI technology to solve scientific problems. What he wants to ask is whether the mechanisms and rules of the problem to be solved can match the internal mechanism of AI.
Sorry, excuse me. I didn't really catch your question.
Okay.
Yes. Whether the mechanical rules problem to be solved can match the internal. Yes, that's actually a very nice question. I think it also related to the what we just talked about, the explanation of the AI. For now, of course, what we want to do is try some baselines on the on our own tasks. But of course, there are some you can also use some other more advanced models like I don't know, PNN based models, and also there are many different kind of GNNs, especially designed for the task with the rules and the mechanisms inside this problem. But for now, we are just using them, the graphs to model, and of course, as a rules, we also have. I think a part of the rules is also included in this design of the descriptors. I think you can put the most important features. As you can see here, this of course is standard, but it's also selected by our chemical collaborators. So this is also a way to design what kind of rules you want to follow. And another one is you can see here the distance here is like this is we want to try that we want to use another ways, another kind of ways to describe the molecules instead of some old ways like the bondings, etc. So I guess you can also try to do this in this way. But of course, design a model which is exactly related to some of the features would also be possible. I think so. Yeah. If you're interested, I think there's actually a conference or a seminar called LOGAJ, which is quite a big one, and they have a lot of talks about this.
Okay, I hope it answered his question. Thank you. Thanks a lot. Thanks
Thank
again
you.
for your talk. So next up is myself. So let me share my screen. Okay. I hope you can see my screen. Okay, so I'm quickly going to talk about what we do at Smart and Spaces. So we use AI for intelligently managing the space. So I'm Vishwas, and I'm also chair of the MCAA India chapter. And at Smarten, I look into data protection and privacy of data. And earlier, I also helped build the whole platform. So we have an AI and IoT platform. So I was directly involved in design and architecture of the platform. Right now, I'm not really involved in day-to-day development work, but I'd like to present what we use AI for space management. And we have a data science team which works on it on a daily basis in terms of coding and development. So what we're trying to solve, so there are a lot of complexities in the workplace. Workplace means it could be your office space, enterprises, and also tech parks, which house many companies. So right now, how they manage space within those enterprises and tech parks is usually manual work and mostly spreadsheets, but not much of it is digitally transformed or automated. So what we've been trying to do at Smart and Spaces is to transition from outdated tools to AI-driven tools, also include IoT wherever possible. So this is to basically to help save space costs and also enhance employee experience because they save a lot of time and resources and also optimize spaces. So many of the enterprises we found that they were renting out or they were holding a lot of space unnecessarily, even though, especially after COVID, not many people were coming to office, so it was all hybrid mode. So they really wanted or looking at solutions which could optimize their spaces. So we have a product called Space on AI. So it has 5 steps. So we have 5 modules, basically. So first one is the data and IoT hub, and we have an AI analyzer, which analyzes the data collected by the data and IoT hub. And then we have the AI planner. So for example, it helps in accurately analyzing the scenarios and your floor maps, and then it will recommend some planning scenarios. And also we have AI forecasting. So based on your future needs, how much space you need, how you can allocate different spaces to different departments because they are the cost centers. So our product Space on AI helps on all these things. So first, it analyzes effectively and it plans according to what your needs are. And also it will help you forecast and manage your space efficiently. And finally, we also have the employee experience. So this is what it is built for because all the enterprises, they want to provide a very good experience for their employees. So we have also built in recommendations so that the spaces that are optimized, they can give very good results for end users, that is employees. So in the first step, what we do is we collect a lot of data from multiple sources. It could be your floor plans or Wi-Fi's and sensors, and also your HR systems. There are also BMS systems and so on. So we collect and consolidate data from multiple sources. In second step, we start analyzing that data. So we understand what are the space trends within an enterprise or a tech park. So we use AI algorithms, and then we analyze by location or each department and the space type. So by using this analyzer, we try to understand which are the underutilized and overutilized spaces. And then we can also predict some trends and also monitor energy. So energy consumption is one of the major aspects of facility management. So we monitor energy and also recommend ways for conserving energy. And also we track booking habits. So which department books which space in which manner, and also what are the insights on the capacity for each department or each company. So once that is done, we have a planner. So inbuilt planner. So we can generate AI generated scenarios for your floor plan. For example, you have the scenario as shown on the left-hand side. We have 2D as well as 3D maps. So how you can configure your desks and meeting rooms, how you can effectively utilize that space. And also it throws recommendations regarding how to efficiently use that space. We also have a feature called automatic stacking. So underutilized and overutilized departments and zones, it will automatically restack and provide you the best solution. And for example, now you have 3 floors but underutilized, and now you want to move to just 2 floors and consolidate. So it will also help you in managing that move. So this is also based on AI recommendations. And also reallocate underutilized assets, because asset management, so for example, it could be your air conditioning systems, it could be your desks and meeting rooms and so on. So how you can effectively use those assets. And also it will throw personalized recommendations for meeting rooms and desks, because people have certain choices, because some they want to sit close to some other departments or some particular colleagues. So it will also throw the recommendations based on the usage by each individual user. So we also have the forecasting. So based on the data provided by the facility management teams, so we can reallocate the department space from one floor to the other, and also show how much energy they can save by doing this. And also you can also automatically revise the layout of each zone, and also forecast for future demand. So if you say 500 people are joining next month or next 2 months, so how you can utilize the existing space, or you actually need extra space on another floor. So it will tell you the recommendations as the headcount increases. So finally, the employee experience. So the end user, who is the employee for each enterprise, so they can view and check, because they have application on their mobile phones. So they can view and check. They can also book based on their requirements on a particular day, and they may be working in hybrid mode, some days in office, some days work from home. So in all those scenarios, they can book meeting spaces, their hard desks, and so on. And also it gives an option to go beyond that. So they could be in terms of campus promotions or booking events, raising requests, and so on. So we have, apart from the space management module, we have the space interactive assistant. So this is mainly for the admin users who want in-depth view of utilization of their space. So these details are generated based on monthly, annual, and department-wise insights. And also they will get real-time booking of desks and meeting rooms and so on. So they can also, based on this data, they can manage the moves and also directly interact with the 2D as well as 3D floor maps. So what we actually use inside our platform in terms of AI. So space on AI consists of space management plus space interactive assistant modules. The space management module, it uses only algorithms for recommendations and doesn't use any Gen AI models. Whereas on the other hand, SIA uses AI models. Basically, the approach is RAG, retrieval augmented generation, and we have an orchestration framework as well. and it's been tested on different models like Gemini, OpenAI, and Llama. And also we have the APIs, OpenAPI APIs, Gemini 1.5 Pro APIs, and Meta Llama APIs also. All of them are supported because some of the customers, they have very specific needs in terms of which LLM they want to use. So we also support different APIs. And one important aspect is this is trained on our product schema definition, and it doesn't use any customer data or personal information. So the impact, what we have seen in the last 6 to 8 months, what enterprises used to do in weeks or months, that they can get it done in minutes in terms of space management. And the overall cost has reduced by 30%. And also it provides frictionless employee experience in terms of everyday space utilization as well as productivity. And the overall cost of space management has been reduced by 80%. So many of the organizations, they want to move to an automated way, and especially using AI instead of doing everything manually. So thank you for your attention. And if you need more information about the product and the company, please visit smartandspaces.com or spaceonai.com. So if you have any questions, please shoot. I will be glad to answer. So meanwhile, the next speaker will be Bin Zhang. So I would like to ask him to be ready for the next session. So if you have any questions, please put them in the chat window, or we can also chat at the end of the sessions. Okay, so the next speaker, Bin Zhang, are you here?
It's
Okay.
me?
Yeah.
It's follow to me?
Yes, please.
Okay.
Thank you. Thanks for joining. And can you try sharing your screen, please? Okay. Yeah, I can see your screen.
Can you see my
Great.
screen?
Yes, yes. Please go ahead.
Thank you. Thank you, everyone. Good afternoon. My topic is about research on end-to-end vehicle-mounted AI large model, integrating perception and design making. Is my outline. I will introduce this research in 3 parts. Evolution of the first one is evolution of autonomous driving models. You know, the cooling trend of RNN and GAN applications in the field of autonomous driving, because the first one is efficiency and real-time requirements, and because the traditional RNNs from low computational efficiency and limited ability to handle real-time perception and design-making tasks when processing security data. The second one is complex and generations ability. The third one is the reason of emergence technologies may make them more efficient and applicable in handling tasks such as perceptions, design making, and planning. just we introduced the CNN and the GAN is before the 2020. From 2020 to present, the Tesla has the first introduce the BEV and the transformer large model, which has the advantages in two parts. The first one is improve the perception ability. The second one is improving generation ability. BEVT and BEV2. These two we can OATF to we can encode the BEV feature and use transformer decoder. So we can use we use end-to-end autonomous driving. And end-to-end autonomous driving refers to a continuous learning and design making progress that can go directly from raw sensor state input to control command output without involved any expert or human designed models. The core perception is to avoid the loss of information during the transformation process. So, with AI large model in autonomous driving, we can use the end-to-end in autonomous driving. It can service as a perception and the prediction and design making and control. Now there are many companies use end-to-end technical so end-to-end autonomous driving is rapidly becomes a new focus in the driving industry. This such as Oppo, Momenta. In China, the Xiaopeng, Changcheng, Xiaomi. So the core model of automotive driving algorithm in 3 parts. The first one is perception model. The second one, perception model meaning contains input data through various sensors such as cameras, LiDAR, and millimeter wave radar. The third one is design and planning control. The 3 part is this is the 3 part of the core model. The environment perception of the autonomous driving. There are 2 mainstream technology route for environment perception technology. The first one is a multi-sensor version section determined by version, with Tesla being the typical representative. The second one is a large solution demounted by LiDAR and assisted by the other sensors, with topical reception such as Google and Baidu. The the current in-car AI big model. The in-car AI big model is a large-scale artificial intelligence model based on deep learning technical designed specifically for the intelligence of automobile, and it can such as, for example, Xiaomi Mi 1.3B large model, Nomi GPT, extremely ZK AI OS system, SIMO intelligence interaction system, Huawei S9 AI large model, and so on. Is the design of the vehicle mounted AI large model from the presentation and to the design control. Many from BUV compared with transformer architecture will become the main development detection in the field of automatic driving. Thank you. It's my presentation. Sorry, because today I have a busy errand. I'm finished. Thank you.
Thank you, Bin Zhang. So any questions for him? Yeah, there is a question for you from Mangal. Currently, besides cost challenges, what are the technical difficulties of intelligent driving? So are there any technical difficulties when it comes to intelligent driving? Yeah, this is the question for you. Can you see the chat window? So, of course, as you mentioned, there are cost challenges, but are there any technical difficulties?
I think I think it's a question idea about to integrate pace detection and design making, where we can use BUV and transformer. Now you know there are many automatic driving industry in company use the BUV and the transformer in their business. So it's a rare area in future. Thank you.
Okay, great. So I think to summarize, yeah, there are many deep learning algorithms or the perception models and decision control systems, but to integrate with many of them and try to come out with an accurate analysis, I think that is the most challenging technical difficulty, I think, in intelligent driving. Because if you see Teslas and all that, they don't use lidar. They're dependent on some other technologies, but many other companies like BYD, they have gone ahead with lidar extensively. So I think there are many technical challenges, especially in terms of integrations. Yeah, thank you.
Yes.
Thanks a lot. So the next speaker is Fan Mo. I would like to invite him to share his screen, please.
Yes. Hello.
Yeah, I can hear you. Can you try sharing your screen, please? Yeah.
Yes. Okay, I can check. So, can see my slide, right?
Yeah, I can. Yeah.
So,
thanks a lot. Thank you. Go ahead, please.
So hello, everybody. So my name is Fan Mo. I'm currently a researcher at the University of Cambridge, and I would like to give you a brief introduction of my research about the robot reconfiguration and based on the artificial intelligence. So as we can see, with the development of the Industry 4.0, the manufacturing industry has revolutionized a lot. So product manufacture become more and more customized. This trend is achieved by innovative techniques such as the reconfigurable manufacturing system. This system is one designed at the outset for rapid change in structure as well as in software and hardware components to quickly respond to market changes. Robots are important in these systems because they provide the agility and precision required to adapt rapidly to new manufacturing process and customization demands. However, despite the importance of applying the robot in these systems, the robot causes challenges. For example, there are data from multiple sources in robot applications. Besides, a robot application must react quickly to the ever-changing process requirements to meet customer requirements. Furthermore, after adaptation, further optimization, especially layout optimization, is needed to ensure production efficiency. Based on this background and challenges, there are some research questions. For example, how can data from various sources be efficiently processed? And how can robotic assembly system adjust to ever-shifting process requirements? And also after adaptation to process requirements, how can a reconfigurable robotic assembly system optimize its operation after adapting to the changes? So the basic idea is to develop some approach at first to effectively managing the data from various sources, and also then design a system which can exhibit agility and responsiveness to changing market demands, and also to further optimize the systems, such as to optimize its current layout, to optimize the job scheduling of the robots. So based on this, there is a framework proposed to address this problem. So at first, we have introduced an experience data bank, which stores heterogeneous data and based on the knowledge graph. And then this data bank can provide guidance about how to select the proper assets for the customer task, and then we can do further optimization. After the optimization, we need also to deploy it. For example, once the location of the robot has been changed or the sequence of the operation has been changed, and we need to also update the control code to control the physical robot accordingly. So there is also a need to develop methodology to deploy these changes. So based on this, so we have proposed the experience data bank, and which uses knowledge graph to enable to store the data from various sources. And to develop this knowledge graph, we need both layer. One is schema layer, and the second one is entity layer. The schema layer contains concepts, properties, and relationships between concepts, and the entity layer contains the specific entities that are instantiated from these concepts. So to build the schema layer, a vendor-neutral autonomy model for robotic assembly is proposed, because in current production, there are different brands of robots, like Fanlook, like KUKA, like ABB, and different brand of robots has different concepts of motion control, and also have different kinematic features. So the target is to propose vendor-neutral ontology models to handle this information. So which means that the model can be applied to almost all the brands of the robots. with one model. So based on this, I have designed a model which can be applied to different brand of robots, and this result is published on the Robotics and Computer Integrated Manufacturing, which is a top journal in intelligent manufacturing. And based on this concept, we can describe the robot specifications and robot capability very easily and quickly. Besides how to adapt to the changes, so we have also designed a model which describes the process and product, and also how we can match the capability. For example, when the customer gave us a new order, a new request, how can our current production line to adapt to the change requests or the requirement. So this model aims to solve this problem, so which can help us to find the most appropriate assets or robots to execute the task. So once the schema is designed, then we need to build the instance based on the schema. So you have designed some algorithms to handle different sources of the data, such as the data from the customer document, the data from the dataset, or the data from the CAD model. So we use semantic models to describe this and use different approaches to extract knowledges from the different sources of data. And then we apply. Can you mute yourself? Yeah, sorry.
Yeah, just to add, those who are not speaking, can you go on mute, please? Thanks.
Yeah. So so then we have applied some techniques to embed the graph and complete the graph, and then accordingly we will update the schema layer. After that one, this knowledge graph has a lot of importance, and we use this one to do semantic search and capability matching and help the decision maker to make decisions. And so the next few slides I will explain. So the detailed approach to apply the knowledge graph to do the decision making. For example, we have to decide which robot to use, and we have defined evaluators to do this, and which can help us to see if the current asset is over-specified or overqualified or not qualified, or what is the most appropriate robots. For example, some robots can do the task, but the cost is too high, or some robots can do the task, but the energy consumption is too high. So we need to consider different aspects to help the decision makers to find the most appropriate assets. After that one, we have developed an optimization framework, which consider the modular aspects, and so to use a general framework to generalize the problems. So like we can use this framework to optimize the layout of the robots, or optimize the control parameters, or optimize the cost. And so this framework can be applied to different platforms. For example, different factories, they use different, for example, software to simulate the process, like KUKA, like Siemens, or like ABB, they have different software. But with our general framework, it can be applied to all of them. So in this framework, we have three environments: simulation, optimization, and modular optimization algorithms, which we can implement the artificial intelligence algorithms, such as deep neural network, reinforcement learning, and graph neural network to do the optimization. So one example here is that I have developed two use cases. One is using the Siemens software, because Siemens is widely used in in aerospace and in automotive. I have to define this environment and digital twin to enable to simulate the task and to optimize the task. And also the other one is the robotic K, which can be also implemented to validate the effectiveness of the framework. So as I mentioned before, once the optimization is done, we need to deploy the changes. So sometimes to update the control code is also time consuming. So here I have defined a concept which is called manufacturing apps. So we can use this framework to deploy the changes very quickly, and it can be deployed in different operating systems such as Linux or Windows or some other systems. And it's acting like apps, so you can download and upload it everywhere in the world. So this one is the other example of how we use knowledge graph to do the capability matching. For example, we have knowledge graph and help us to find the most appropriate assets to do the task. For example, if the customer requires some task of welding, so we need to find the proper robot and the proper end effector to do the task. Besides, we have generated this simulation environment to do layout optimization to help to increase efficiency, such as to reduce the cost, to reduce cycle time, and also to improve the robot's malleability. The other example is here. We have different algorithms here to apply here to do the optimization in one of the operation of the aerospace manufacturing. And so after optimization, this new layout can be confirmed to do the task, and then this new layout will be applied to the physical layout with our deployment framework. And also for single robot, we have the other ones to do the task, and which can also optimize how the robot can do the task more efficiently. Okay, so the other one is that one we have also defined or designed interface to control the robot more efficiently. For example, once we have deploy the task, and we need to make it quicker to execute the action. And so we have implemented here the large language models to control the robot. For example, we can here just type some natural language, and with our code, so the natural language can be converted into the robot control code to make the robot move, to make the robot execute its task. So we can write here, for example, here, get the current pulse, and remember it as home office. So we just write this command, and we use move forward. In this case, we just need the natural language to control the robot, so which is very efficient to control robot and to update the changes. Okay, so I think this is all from my today's presentation. So any questions, or if there are any potential collaboration chances, or just feel free to contact me. Thank you. Yeah.
Thank you, Fan Mo. So it's a very nice presentation. So any questions to Fan Mo? Okay, just a quick question, because you're also integrated with the Siemens ecosystem, so how open is your Like if you have APIs, for example, for integration, are they open, or do you also publish your data data sets for others to consume, or how is it?
Yeah, and I think that's a very good question because Siemens is kind of close, and they require lots of budget. If you want to learn Siemens, you must pay a lot to learn the software. So it's because our lab has a license already, so we can use Siemens software, and so we have collaborated with Siemens a lot, and we co-developed this this solution. Yeah.
Okay, great.
But
so
in case if we want to start from scratch, I think it's a little harder. Yeah.
Exactly. Yeah, I get it. Yeah.
Yeah.
So, okay, if in case there are no more questions, next speaker is Ravi Pratap Singh. I would like to invite Ravi, and can you please share your screen? Thank you.
Thank you. Yes, I'll share my screen.
Yeah. So for the audience, this is the last but one presentation. So after this, we have one more presentation. Thank you. Please go ahead, Ravi.
Just change my setting. Okay. So hello everybody. I am Ravi Pratap Singh. Today I'm going to share some of my learnings about GraphRag. It is a unique approach. I would not say exactly unique, but it's a new approach to work upon the private data set. First thing first, this presentation or slides, whatever I'm sharing, it's represent my own personal views. It's not, I'm not speaking for my employers or collaborators. So what I am going to cover in the next 7 minutes is what is GraphRag, why it's important, and how it works in theory, because I do not have information to share on the practical basis as of now. So in today's business context, every organization has a very complex and interconnected system, and these organizations require smart tools to navigate the decision making. Because every organization is sitting with huge amount of data. When I say data, it means the data is in the, let's say, private data. The company has, example, retail companies, pharma companies, manufacturing, shipping organization. Every organization has a lot of information about customers, businesses, processes, and all these avenues. A good chance is our opportunity is to how to exploit generative AI with this particular private data. And with objective that this particular private data will help these organizations to go with the customer or go before the customer with enhance efficiency, productivity, and reduce the time for the delivering this amount of services. So to solve this particular step, there are different, let's say, different algorithm or system have been followed. Let's say, a company has a huge amount of private data. So initially we had that every large language model, which is actually using as a resource for the generative AI solutions, it depends, or its efficiency or accuracy depends on the data. So if our data is the private, it means the LLM directly cannot be used. They have to be kind of fed with the contextual information. To solve this particular issue, there have been different approaches. Like we have database engine, and they has limitation. They cannot, let's say, extract the relevant information or the contextual information on time. Then there is the second solution called retrieval augmented generation. It has partially solved the problem, but it has a limitation like low recall and the limited context. If your data is used, for example, let's say 100 of terabytes of data for last 20 or even the 10 years. In those scenarios, the GraphRag is a new approach. And what is the GraphRag? GraphRag is based on knowledge graph based RAG, and it is open source Python library. And what it does that when we have particular data, those data are fed to the large language model, and those large language model will generate or extract the entities, relationship, and communities between those data. And in place of organizing those data in a structure or unstructured format, now the whole information or data is converted into this graph architecture. And what is the advantage of graph architecture? That it now every, let's say, point or data in this graph architecture has a direct or indirect relationship with another entities. And these entities are very useful when we are extracting or we wanted to know some relevant information between these data points. And what is happening inside this graph rack is that this is the overall so it could be structured as well. I mean, documents are connected with the DB engine. Those information are fed to the large language model. In the large language model, will definitely because this is the element. It needs data here what it is supposed to do. So we define it to extract the relevant
Ravi, you are breaking. Can you please check? Your voice is breaking. Can you just check this? Yeah.
Is it good now? Better?
Yeah. Better now. Yeah, thanks.
Okay. So out of these, we have the extracted graph, and this is the knowledge graph, which is very much important for the whole graph rag exploitation. And how it is different from the typical, let's say, knowledge graph, because the graph rag library does not dependent only on the node and the entities and relationship, but it also creates some kinds of communities. Communities are like we have 8 data points, and these 8 data points are connected. But to search globally, we wanted to again make those eight data points into sub-communities, so that in the query time, when we ask our relevant questions or initiate a query, then those query will pass to these communities, and those communities has a better kind of affinity to be relevant and fed to the large language model for the further processing. So once we have the extracted graph or knowledge graph, so overall architecture is something like that. So this is the indexing time, and this is the query time. We have data, we have prompt, pass it to the large language model. It will create the knowledge graph. Once we have knowledge graph, then a user can put a question. That question will pass through this generative AI application. And here we have a lot of tools to integrate and play along with over here. And then this particular query will pass it to the let's say this knowledge graph, and here the communities and this relationship are playing important roles, because as I have earlier said that LLMs has affinity to give relevant results, reduce hallucination if we are giving contextual information, not the near about true, but let's say very, very contextual and to the point information. In those cases, these knowledge graph are very much pertaining to giving good results. And here we are seeing 2 kinds of retrieval. One is graph retrieval, one is the document or contextual retrieval. I'll say this is graph retrieval is something if you wanted to understand the overall context, like you have data of last 5 or 10 years, and we wanted to understand what are the key points, because these points are not, or the answer which we are looking for, this is not on a particular document, but on the set of documents. And those set of documents are organized in the nodes and the relationship. or entity and relationship, and they are further summarized in the form of communities. So for the global answers or the overall picture, we can get the retrieval-based information, or if we wanted to put very to the point exact information, like what was the let's say very quantitative numbers, like what is the growth rate for last 2 or 3 years, because these information are exactly on a particular content in the information or knowledge graph that can be passed through the document or context embedding. In here we have the ability to use the vector databases because they are directly and very fast and not so much computationally extensive. So in general, this is the overall graph rag architecture, and to work or use this graph rag architecture, the Microsoft has open source graph rag library, and they have many companies are using nowadays last 2 or 3 months for the different kinds of application. And the good part about this particular graph rag is that it has shown the potential that it revealed the hidden relationship, which is not visible by reading 2, 3, or 4 pieces of paper. But machine can read hundreds and thousands of pieces of information and then organize that information in the form of graph. And it can cover the complex pattern, because the complex pattern, which is very much important to reveal, as we see that we know very less about ourselves than the machine learning algorithm, because they have find out the hidden pattern about us. So in the similar way, the graph rag help to let's say find out the complex pattern. And of course, the ultimate purpose of this is to increase our productivity and serve the customer in the very short amount of time. And very important part is that this particular graph rag or knowledge-based rag can be integrated with the agentic framework. We are hearing for last let's say 1 year, the agentic framework. And nowadays, every companies, whether it's like Llama Index or the other, every company has their ecosystem of agents. And now those agents are interacting with these graph rag or rag-based approaches to serve the customers in a better way. And it has a potential to good. I mean, it is showing a potential to be in sync with the graph rag and the agentic framework hand to hand and solve the customer's problem. I believe this was my last slide. And if you have any questions, we can discuss over here or at the end of the sessions.
Thank you, Ravi. That's a very interesting presentation. So any questions for Ravi? So if not, I have a quick question, Ravi. Please go ahead. Yeah.
Hi, sorry. Hi, Ravi. Hi, it's Lilin. It's very nice talk, and I'm really interested in it. Actually, I'm also involved in companies using this large language models for fintech. But if it's possible, I would like to ask like a practical question. Is like, have you ever have any comparison between the raw rag and the graph rags, and say how much improvements is there, like for real life applications?
So let's say there are 2 kinds of scenarios. We did something. So for the naive rag, if we wanted to ask a particular question, example, what was the growth rate for last quarter or last let's say last 2 years? And for these kind of simple answers or simple questions, which can be find out in a particular piece of paper, the naive rag is good, because we have to look into the cost associated with building the knowledge and how fast it can give the results. So on the very simple task, we have the naive rag, which is giving, I mean, there is no comparison. But if we ask a same knowledge library, a different question, summarize the 5 key points for last 2 years in our company. In those scenarios, because the summarization of the key points, this piece of information is hidden on different pieces of information, different pieces of let's say chunks of information. And when we have different pieces of chunks, in those cases, the context is somewhere lost. So that's why these knife rag or vanilla rag does not work on those information where we wanted the global answers. In those cases, graph rag has a better answer, but of course it has some associated complexity in terms of creating the knowledge graph, and creation of knowledge graph is almost 10 to 15 times costlier than the knife rag. So in short, for simple answers, the knife rag is good. But if we wanted to put the holistic or wanted to know the holistic understanding about the data, then on those cases, the graph rag is the solution. If we wanted to know something in between the lines of those hidden pieces of information, then graph rag is something which we can try upon.
Okay, thank you. Just one more further question about this graph rags. I didn't really know how you say it, but are they created like handcrafted, or it can be learned somehow automatically? Like the graph knowledge graph, sorry.
Okay, so let's say there are two ways to create the knowledge graph, which is the traditional ways, because knowledge graph is not the new. We have the computer science people are doing for last 30 or 40 years. Because now we have the large language model, which is better in certain tasks. And extracting the relevant node, or let's say entity and relationship from the text data document, it is better at. That's why we can use these LLMs to extract the entities and relationship from the graph and then create the knowledge graph. So as I have shared with here, so here the LLM is a key piece of information because this is the input and this is the prompt. So we are giving our information structure or unstructured data, let's say hundreds of terabyte or petabyte information. We have subjected that we do not have limitation on the cost associated with the LLM. It can extract entities and relationship. And out of those entities and relationship, it can create the knowledge graph. Now, because this knowledge graph is based on the LLM information, which is dependent on this information and the prompt, I mean, it is better than the creating the knowledge graph traditional ways. So that's why I would say this is something which we can rely upon, and there are ready-made systems to check the accuracies and the consistencies of the knowledge graph. I believe that is my response.
Okay, thank you very much. Maybe we can discuss more about it later afterwards. Thank you.
Sure. Any other questions?
Hi, Ravi, can you hear me?
Yes, I can hear you.
Like, I just want to know, like, when you break this unstructured data into like extracted graph, like normally what I have studied, like in RAG, you convert it into chunks, and then on those chunks you like apply vector database and then do some kind of a retrieval search. How do you like break this unstructured data to form a kind of a graph?
Sorry, guys, Masood and Ravi. So, in the interest of time, we have one more speaker, and I would like to finish that talk and then take these questions later, if you don't mind.
Yeah,
Okay.
sure, no issue. Thank you.
Okay, thank you.
We'll connect after this. Okay.
Yeah.
Thank you.
Sure. So there is a Q&A session after all the talks are over, so we can continue discussing there. Thanks, Ravi. Last but not the least, our next speaker is Zikai Yang. Can I request you to please share your screen? Zikai, have you already logged in? Not sure if he or she has logged in. So just the last call for Zika Yang. If you have logged in, please unmute yourself and share your screen. Okay, looks like our last speaker hasn't joined. So before we conclude and open the session for further discussions, I would like to share my closing remarks. So I'd like to firstly thank just a minute. Okay. So first of all, thank you all the speakers. It was really great having you during the last 2 hours for this MCAA Connect session on computer science and AI. A lot of insightful talks and varied topics. It varied from material science, AI governance and ethics, smart search, increased user experience, chemoinformatics. I heard it for the first time. Space management, autonomous driving, very interesting topics, and also manufacturing and robotics. And also, of course, graph rag, which is pretty new, I guess. A lot of interesting questions around all the attendees. So a great way to express our work and also see opportunities for collaborations. I'm very sure a lot of us would like to collaborate with each other and try to solve our problems in a more efficient way using AI. So on behalf of all the organizing committee, that is MCAA China chapter, Japan chapter, Southeast Asia chapter, and Research Funding Working Group, and India chapter, I'd like to thank all the speakers and attendees for making this time out and attending on a Saturday. I know it's pretty tough. So thank you again, and we'll definitely look forward to seeing you in some other events. Please follow us on our website, which is marycuriealumni.org. We're also on LinkedIn and Twitter. And we also have a general interest group on AI within MCAA. So if you go to our website, you can also follow the general interest group. And they also organize a lot of events, not just once in a while, but almost every week. So there is a lot of stuff going on in the general interest group, and it's free to join for everyone. So please explore that option. And certificates for all the speakers and attendees will be shared once the event is over. So it may take a bit of time because they are being designed by our communications team. So probably a couple of weeks. So please bear with us. We'll definitely come back and share them with you when they're ready. Okay, so from my side, those are the closing remarks. So we still have time, like 7 minutes until the official closing time. So I think some of you had more questions for Ravi, so feel free to ask them now. I would ask Masood, if you are here, please continue discussions. And if anybody else has questions, please raise your hand and we can take them up in the next 7 minutes. Thank you.
Thank you. But I think I asked question like if Ravi could address it. Is it okay with him?
Yeah. Okay. So there is a kind of difference when we say we are moving through the vanilla RAG and the graph RAG. Because the graph RAG library offers two kinds of search, local and the global. So for local search, it also kind of create the index file, typical the vanilla RAG way. But for the graph RAG or answering the global question, it kind of initially, suppose you have 10 documents. And in the first instance, these particular documents are passed and we have the chunking mechanism where, let's say, suppose we have the chunk size of 1200 tokens. and there is an overlap of, let's say, 20% of the overlap. So in the first instance, those documents are break into the chunks, and now these different chunks are passed to the LLM with a prompt stating that you are expert. Now your objective is to create or extract the entities and relationship, and then try to manage those entities and relationship in a structured way. So what it does that, I mean, of course, it is all happening inside the GraphRag library, because not directly the LLM is unable to answer. So there are some fine tuning or something happening on the GraphRag library that it will extract the entities and relationship, and those entities and relationship now, let's say, index in a certain numbers, like identifiable number in the machine base, and the second is the human readable, like numbering 1, 2, 3, 4, 5, 6, 7, something. Once the entities and relationship are extracted, then these entities or relationship are grouped, and those grouping is happening in a very hierarchical way. And there are, I believe, there are 2 or 3 algorithms, out of which one particular algorithm is used in GraphRag libraries to create the communities. Communities is just like we have 10 documents, and try to group these 10 documents into 2 or 3 sub groups. And those kind of communities are the key points, because these communities are later used when we are trying to extract the information given a contextual query. So in the pipeline, we have the whole document. Those document is passed into the different chunks, and there is a optimization happening over there. Those chunks of information passed to the LLM with a certain a kind of, let's say, contextual query or the prompt, and that prompt is helping the LLM to extract the relevant entities and extraction. And after that, those entities and relationship are extracted, then there is an algorithm which is being used to create the hierarchical communities, and those communities are later organized inside, in, let's say, holistical manner as a knowledge graph. And that knowledge graph is a reference when a user comes, and let's say if it says that, okay, give me this particular information in local ways, then knowledge graph is not let's say passing through the whole, let's say LLM is not extracting the whole knowledge graph, but it is only passing the indexes, because it's locally. And if we say, give me the scenario of last 2 years or 3 years, or we are passing that, okay, this is the global query, in those cases the query is passed through these different knowledge graphs and the communities, because those communities have the relevant information. And I mean, basically, knowledge graph is created in such a way that it will create all the relationship. It means how many entities have been called how many times. Let's say if a particular entity is called 10 times, it means it has a more affinity, that there is a strong relationship. So when a user asks a query on those position, those top 5 or 10 let's say entities are, there is a probability that they will be passed to the LLM for the contextual information. So I mean, of course, I have shared that particular link as well, Microsoft GraphRag library, and that library has supplemented with a research paper, and that research paper has an indexing pipeline, what is happening on those creation or extraction of these knowledge graphs. I mean, from outside it's look very nice and good, but I mean, backside a lot of things are happening. That's why now it's working. And
so, like, basically, the graph is made by LLM itself, given that entity and the relationship.
LLM is extracting the entities and relationship from the text
documents, yeah.
Document, and then those entities or relationship are passed through the GraphRag library, and that library is helping to create the GraphRag or knowledge bases. Because of course, this creation of the knowledge base is not depends on the LLM. LLM is only extracting. There is a hidden graph-based machine learning algorithm that is helping to create the GraphRag or knowledge base.
Okay, thank you.
Thank you.
So, Ravi, is it LLM agnostic or is it closely dependent on the Azure or Microsoft ecosystem?
So because this is what I have explored, it's like at the moment, by default
Closely.
settings are for Azure OpenAI.
I see.
I believe apart from the Graph Rag, this particular framework, there are parallel framework happening in Llama Index and other companies which are working on the RAG system basically.
Okay.
So there is a possibility that you can choose and pick your own LLM, because role of LLM is only to extract the entities and relationship, and those
Correct,
information is passed to the library, and later it's like going to be taken care by the GraphRag libraries. I believe, if I would say, it is not dependent on the Azure OpenAI. I mean, even you can choose and pick your own customized, I'll say fine-tuned LLM as well, even on the local machine.
Yeah, because that would be really helpful because it seems to solve the complex data issues, right? Because as long as the data is complex, the RAG sometimes is not very convincing. So GraphRag, if it can address complex data and multiple sources, different data sets, yeah, I think that would be really helpful because that's what we have seen in real-time scenarios. Yeah, we try to make it as agnostic, LLM agnostic as possible, but yeah, as you said, right now, closely linked to Microsoft Azure, but yeah, as you said, each LLM will have its own framework when it comes to Graph RAG. Yeah, thank you. Any more questions? I think some of the speakers are still here, so anybody in the audience, if you have any questions or you want to collaborate, you can directly reach out to them. And also, next couple of minutes, we'll close in probably a minute. Okay. So looks like no more questions. So once again, thank you everyone. Have a nice day, and we'll see you in some other event. Thank you. Bye-bye.
Thank you.
Thank you, everybody.
Thank you, everyone.
Thank you.
Bye.
Thank you.